All right, so welcome again to today's math class. We have our question on the board. We have that 2 raised to the power minus t is equal to 3 plus t. And we're supposed to find the value of t. Now, let's get right into it. Now, in solving this question, we're going to employ the Lambert W function. And this is the function or the formula that's going to help us solve this question. All right, so we're going to start by dividing the left-hand side and the right-hand side by 2 raised to the power minus t. So it becomes 2 raised to the power minus t equals 3 plus t divided by 2 raised to the power minus t divided by 2 raised to the power minus t. Left-hand side cancels out. We have just 1. And so this becomes 1 equals 3 plus t divided by 2 raised to the power minus t. Now we can rewrite 2 raised to the power minus t to become 2 raised to the power t if we move it from the denominator to the numerator. So now we have 1 is equal to 3 plus t, 2 raised to the power t, right? Now we have t at the power and also t at the base. Now the W Lambert function states that a raised to the power ea is equal to a. So our task is to rewrite the left-hand side and the right-hand side of our equation to fit into the Lambert W function. Okay, so we have a at the base there, we have a at the power, we have an e as well. So our equation needs to fit into this formula so we can be able to find the value of our t. So let's carry on. Now we have 1 equals, we have 3 plus t at the base and then just t at the power. So to make the base look like the power, we need to introduce 3 at the power. Now to introduce 3 at the power, we need to multiply both sides, the left-hand side and the right-hand side, by 2 raised to the power 3. Now, if we multiply by 2 raised to the power 3, why do we do that? Because this way we have 2 and 2 as the basis. And if we have same base, we can always add the powers. From the formula, a raised to the power m, a raised to the power n becomes a raised to the power m plus n. Okay? So from that formula, we're going to rewrite that part of the equation, and it becomes 3 plus t, 2 raised to the power 3 plus t, or t plus 3. Doesn't matter. Now, we have base and power looking the same. There's nothing on the left-hand side yet, or we're supposed to multiply both sides by 2 raised to the power 3 as well. Now, there's nothing happening on the left-hand side at the moment. We're on the right-hand side. So now we need to introduce our e. And to introduce e, we know that e raised to the power ln of x is equal to x. Okay? So our x can be any number. It can be 1, can be 2, can be 3. E raised to the power ln of 4 is equal to 4. E raised to the power the ln of 5 is equal to 5. In our case, we have 2. So e raised to the power the ln of 2 is equal to 2. So let's represent 2 with e raised to the power the ln of 2. So 2 raised to the power 3 is 8 equals 3 plus t. E raised to the power the ln of 2. Sorry. Ln of 2 raised to the power 3 plus t. So we write that. Ln of 2 raised to the power 3 plus t. Yeah, that's looking better. And here's our formula here again. Okay. Right, so we can move 3 plus t to go behind ln 2. And this whole thing becomes 3 plus t e raised to the power 3 plus t ln of 2. Now we notice that we've introduced the ln of 2. And that means the base needs to have the ln of 2 as well. And for this to happen, we need to multiply both sides by ln 2. And if we do that, becomes ln 2 times 8 equals 3 plus t ln 2 e raised to the power 3 plus t ln of 2. So now we see that the power and the base are the same, and also we have our e represented. So this Lambert W function can now be achieved. So we apply the function to both left and right sides of the equation. So now we have ln of 2, 8 equals 3 plus t ln of 2. Now, we move over to the left-hand side and do the same thing to the left-hand side. Try to rewrite the left-hand side to fit into the Lambert W function. So now we have that we have 8. So what do we do to 8? Let's try to rewrite 8. 8 is the same thing as 4 times 2, right? 8 is the same thing as 4 times 2. And this is what we have on the right-hand side. 4 is the same thing as 2 squared. 2 is the same thing as 2 raised to the power 1. Doesn't matter. You can still write it as just 2. So we take this 2 raised to the power 1 and send it behind our ln 2. So we have 2 ln 2, 2 raised to the power 2. If we now introduce our e ln of x formula to 2 raised to the power 2, becomes w 2 ln of 2 e raised to the power ln 2 raised to the power 2. These two can come behind and become w 2 ln 2 e raised to the power 2 ln of 2, and everything is equal to 3 plus t ln of 2. Now we see that the base and the power are both looking the same, and we have our e represented as well. So Lambert W function is satisfied. Therefore, the left-hand side becomes 2 ln of 2 equals right-hand side, which is 3 plus t ln of 2. Now we have ln of 2 on the left side, ln of 2 on the right side, and the ln of 2's can cancel out. And then what we have left is 2 equals 3 plus t. If 3 goes over to the left-hand side, becomes 2 minus 3. T is equal to minus 1. Now, to verify this, because we need to verify to make sure that our answer is correct. So we go back to our equation. Our equation states that 2 raised to the power minus t is equal to 3 plus t. So we have 2 raised to the power minus t is equal to 3 plus t. And we found the value of our t to be minus 1. So everywhere we see t, we plug in minus 1. So this becomes minus 1, 3 plus minus 1. Minus times minus is equal to plus. So this is plus 1. 3 plus minus gives us minus 1. 2 raised to the power plus 1 is the same thing as 2 raised to the power 1, which is equal to 2. 3 minus 1 will get 2. So from what we see here, our left-hand side is equal to our right-hand side. Therefore, our value of t, which is minus 1, is correct. So, if you've learned something new today, make sure that you like this video. If you like what I'm doing, subscribe. And also make sure that you share this video so somebody else can learn something new as well. I'll see you on the next one. Bye-bye.